Hey guys, so I wanted to create just a real quick video just to talk about how we can quickly determine if quadratic equations have two solutions, one solution, or what we say is no real solutions or no real roots. All right, so first we're going to look at graphs. So we know our quadratic functions all make what we call a parabola. So if you'll notice, I don't have any roots here, or my parabola does not cross my x-axis anywhere. So these are imaginary roots, or we're going to say no real roots for what we're talking about. In Algebra 2, you'll talk about it as being imaginary. Here, our parabola, our vertex is on the x-axis, so that means that we have one solution or one real root here. And then if our parabola crosses our x-axis in two places, then we have two real roots or two solutions. So we can take our equations, our quadratic equations, and we can determine how many solutions or roots we'll have very, very quickly. So I wanted to show that to you. All right, so when solving, we can tell the number of solutions just by looking at what we call the discriminant. All right, so that's a good vocabulary word, the discriminant. In the quadratic formula, so let me jot that down right here. If we remember our quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. The discriminant is the expression under the radical. All right, so this is considered the discriminant. This is the expression we simplify, and then we take the square root of it. So depending on what we get for this expression, it will tell us how many roots we're going to have. Okay? If our discriminant, if I plug in my values for a, b, and c here, and I get a positive value, then we're going to have two solutions. All right, because I'll be taking the square root of a positive value. So for example, the square root of 9 will give me two values, both positive 3 and negative 3. So we will end up with those two, plus or minus those two roots. If the discriminant is 0, in other words, when I plug in a, b, and c here and I simplify, if I get 0, then there's only one solution or one real root, because the only root of 0 is 0. I'll end up with the square root of 0, which I can't say is positive or negative 0, right? It's just 0. So there's only going to be one solution or one root. If the discriminant is negative, so if I plug in for a, b, and c here and I get a negative value, then there are no real solutions, okay, or no real roots, because we can't take the square root of a negative value. So if I simplify this and I get negative 9, I can't take the square root of negative 9. There's nothing times itself that will give me a negative. So this is what you'll learn in Algebra 2 as an imaginary number, but we're going to say right now that it just has no real roots. So that means that our parabola is either opening up above our x-axis or opening downward below our x-axis. So in other words, something like that or something like that. All right, so let's determine the number of solutions. So if all I have to determine is how many solutions there are, then I'm just going to use the discriminant, b squared minus 4ac. All of these are in standard form, so all I have to do is plug them in. So b squared here will be 16 minus 4 times 1. So I have 16 minus 16, which gives me 0. So under that root, I'm going to have the square root of 0, which is just 0. So there's only one solution. All right, the next one, I have negative 5 squared is 25 minus 4 times 1 times negative 2. So I end up with 25, negative 4 times 1 times negative 2. That'll end up with being a positive 8, so plus 8. So I get 33. That's a positive number. So when I take the square root of 33, I'll get the positive or negative root of 33. So I will have 2 solutions. And then the last one here, b value is 1. So 1 squared is 1 minus 4 times 5 times 6. So 1, this will end up being minus 20 times 6 is 120. That'll give me negative 119. That's a negative. I can't take the square root of a negative 119. So this means that there are no real roots. All right. So there's no value, no real value that I can plug in for x here that will make this work. Okay? All right, hope that made some sense to you, and I hope you're having a great day. See you later.